Greetings everyone, and welcome to the next video in my lecture series on differential equations. We are still working on Laplace transforms, and in this video we solve another initial value problem using Laplace. So as you can see, our example is we're going to solve the following initial value problem using Laplace, and the differential equation is y prime minus 2y is equal to 3 cos 2t if y of 0 is equal to 0. So let's get started. For our answer, we're going to first take the Laplace transform of both sides. The y prime, the very first term, is going to become s capital Y of s minus y of 0. So the y prime term becomes these two terms, and then we subtract 2 times the Laplace transform of y, which is just capital Y of s. And now we take the Laplace transform of the right-hand side, so it's going to be 3 times the Laplace transform of cos 2t, which gives us s over s squared plus 4. Now notice that our initial condition, y of 0 is equal to 0, and so our initial term here is just going to go to 0, and what we're left with on the left-hand side, if we factor out a y sub s, is we get s minus 2 onto capital Y of s is equal to 3s over s squared plus 4. And then solving for y of s, we get 3s over s minus 2 s squared plus 4. Now, in order to do this, we're going to need partial fractions. So I'm going to just draw a little box. So partial fractions. S over s minus 2 onto s squared plus 4 will give us a over s minus 2. It's a linear factor on the bottom, so we just have a constant on the top, plus something over s squared plus 4. It's a quadratic on the bottom, so we need a linear term on the top, so we can have bs plus c. And multiplying both sides by the common denominator will give us that 3s is equal to a onto s squared plus 4 plus bs plus c onto s minus 2. Now you have a couple of options here. Let me rewrite the left-hand side as 3s, not 35. You have a couple of options. I'm going to just choose a couple of nice values for s, but you could also expand the right-hand side and then collect like terms and match coefficients. But I'm going to choose s is equal to 2. Then the left-hand side becomes 6. The first term with a becomes a plus 2 squared plus 4. So a times 8, that should be an equal sign. So 6 equals a times 8. Plus, and then putting in s equals 2 makes the s minus 2 term 0, so that gets 0. And a is equal to 6/8 or 3/4. And now we're going to choose s is equal to 2i. Again, if you're not a fan of complex numbers, your choices are to just multiply out the equation on the right, or the terms on the right-hand side, and then match coefficients. Or if you prefer, just do s is equal to 0 and s is equal to 1 instead. That would totally work. If you put in the s is equal to 0, it'll knock out the b term, and then just choose 1 for ease of calculation. but I like complex numbers, so I'm going to put s is equal to 2i. Then the left-hand side becomes 6i is equal to, notice that the s squared plus 4 term will be negative 4 plus 4, and so we get 0 for the entire first term, plus 2bi plus c onto 2i minus 2 is equal to, and then multiplying out, foiling out, you get minus 4b minus 4bi plus 2ci minus 2c. And so you get a nice little system because the left-hand side is 0 plus 6i, and so your real terms are negative 4b and plus 2c. Oh, whoops, nope. Negative 4b and the minus 2c, and so you get that 0 is equal to minus 4b minus 2c, and then you also equate the imaginary terms. 6i is equal to minus 4bi plus 2ci, which if you solve the top equation for c, you get c is equal to negative 2b. If you take the bottom one and divide each side by I, and then divide each side by 2, you get to 3 is equal to negative 2b plus c. And if you simply make a substitution here, then negative 2b down here, if you replace it with c, you get that 3 is equal to c plus c. So 3 is equal to 2c, and c is equal to 3/2. Plugging it into the top equation, you get that b is equal to negative 3/4. Okay, so going back to where we were, that means that, so capital Y of s is equal to 3s over s minus 2 s squared plus 4. Placing in our values for a, b, and c that we've just found, we get 3 over 4s minus 2 plus a negative 3/4 s plus 3/2 all over s squared plus 4. And what we want to do is we want to write the right-hand side in the exact form that you'd find on your Laplace transforms sheet, so that we can take the inverse Laplace transform of both sides. So this is 3/4 times 1 over s minus 2, and that's a nice straightforward one, minus, and now I'm going to take that second fraction here, and I'm going to split it into two terms. The first term, I'm going to worry about the constant out front in a second. I have s squared minus 4 in, s squared plus 4 in the denominator. And I've got negative 3/4 s in the numerator for the first one. So I'm just going to pull out the negative 3/4 in front, because s over s squared plus 4 will just give us a cosine term. And then for my second fraction, the 3/2 over s squared plus 4, I have a constant over s squared plus 4. What I really want is for the numerator to be 2, because the denominator is s squared plus 4. And if you look on your Laplace transform sheet, excuse me, and if you look on your Laplace transform sheet, you can see that sine omega t is equal to omega over s squared plus omega squared, so I really want a 2 up there. And the way to make this work is to make our factor out front 3/4, because if I multiply 3/4 by 2, I get 3/2, and then the 3/2 is, let's just do some circling here, then the 3/2 that I have down here is equal to the 3/2 that I have up above. And now I can just take the inverse Laplace transform of both sides, and so I get that y of t is equal to 3/4 e to the 2t minus 3/4 cos of 2t plus 3/4 sine 2t. And there's our answer.